Pydantic AI's agent framework routes concurrent execution through a capability layer. And the ThreadExecutor capability is the mechanism for supplying a custom thread pool when sync tool functions or callbacks need to run outside the default ephemeral threads. The code block below demonstrates the minimal initialization pattern for wiring that executor into an agent configured against a model provider. Configuring a ThreadPoolExecutor with a worker count and name prefix, then passing it via the capabilities parameter to the agent constructor, is the complete setup required to keep thread lifecycle management under explicit application control in long-running servers. From concurrent futures, import ThreadPoolExecutor. From Pydantic AI import agent. From Pydantic AI, capabilities import ThreadExecutor. Executor equals ThreadPoolExecutor max workers equals 16. Thread name prefix equals agent worker. Agent equals agent openai. GPT-5. 2. Capabilities equals ThreadExecutor executor. This sets up a shared ThreadPoolExecutor with 16 workers and passes it to the agent via the ThreadExecutor capability, replacing Pydantic AI's default ephemeral thread creation for sync tool functions. The thread name prefix makes worker threads identifiable in profilers and logs. The pattern matters for long-running servers like FastAPI, where default NEO to thread run sync, threads can accumulate under sustained load, causing resource pressure. Using a bounded pool with a named prefix gives you control over concurrency and observability, though you trade per-request isolation for pool reuse. If a sync tool blocks or leaks, it ties up a worker until the pool exhausts. Let's break it down line by line. From concurrent futures, import ThreadPoolExecutor. Imports ThreadPoolExecutor for running tasks concurrently using a pool of threads. From Pydantic AI import agent. Imports the agent class from Pydantic AI, enabling creation of AI agent instances. From Pydantic AI, capabilities import ThreadExecutor. Imports ThreadExecutor from Pydantic AI, capabilities, making it available for managing threaded execution of agent tasks. Executor equals ThreadPoolExecutor max workers equals 16. Thread name prefix equals agent worker. Creates a ThreadPoolExecutor capped at 16 workers, assigning it to the name executor with threads prefixed agent worker. Agent equals agent openai. GPT-5. 2. Capabilities equals ThreadExecutor executor. Creates an agent instance bound to the GPT-5. 2 model and configured with a ThreadExecutor capability, wrapping the provided executor object. That's the whole picture. Pydantic AI's capability layer gives you a clean plug point for threading, and ThreadExecutor is the mechanism that swaps out the default ephemeral threads for your own ThreadPoolExecutor. Wire it in via the capabilities list when you construct the agent, and every sync tool or callback runs through your bounded 16 worker pool with identifiable thread names. The trade-off is real. You gain control over concurrency and observability in long-running servers, but you lose per-request isolation. A blocking or leaking sync tool pins a worker and can exhaust the pool under load. The model string and executor just sit there as configuration. The capability does the actual routing.
16 named threads race through the quiet futures while the agent holds still.